Summarizing the effects, the electronic effects of the activating groups, so the ones that react faster than benzene in electrophilic aromatic substitution, we said that all of these groups activating this reaction are ortho-para directing as well. Meaning, if I have something here that is activator, that may call this like Z. I'm going to put it elsewhere because of that. Let's see. Ortho-para directing. So let's see that I have here that group, Z. So I'm going to be directing ortho and para to that. Okay, so activators do that, ortho-para, and I'm just showing with the arrows the position. Now, there are other groups that actually make the, say that your baseline is a benzene. So some substituents at the aromatic ring make the compound react slower than benzene. So see some of those. Take, for example, nitrobenzene. And nitrobenzene, I'm going to draw it like so, explicitly. Here you have a formal positive at the nitrogen. So nitro group is a strong electron withdrawing group. You can do resonance toward the ring. You can do this and create the following resonance structure. And when you do this, notice that I am creating, in this structure, I will have a positive charge here. So notice where the positive charge is. You can continue doing resonance, and that will place the positive. Now, here at the para position, so para to the nitro group, here I will have negative, negative. I'm drawing the electrons this time. So notice positive here, and you will have another structure, if you do this, in which the positive charge is, again, positive, but at the other ortho position, plus negative and negative here. What that means is that the aromatic ring now has less electron density. And recall that this is a nucleophilic attack. The ring acts, the aromatic ring, so the pi electrons act as nucleophile over to the electrophile in that reaction. So if we make this poorer, let's say, in electron density, we're making the nucleophile weaker. So these groups that are electron withdrawing groups, because they remove electron density from the ring, they are deactivating. So activating are electron donor groups. Deactivating are electron withdrawing groups. So one example is the nitro. What would be then the, say, the hybrid of resonance? Then you will have delta positive here, delta positive at the other ortho position. Let's do dot, dot, dots. Now, what we see here is that we have also positions at the ring that have even less electron density. So not all the positions are the same. So more electron density relative to this is at the meta position. So it's not as deactivated, let's say, at that position. So deactivating groups as the nitro group are meta directors. Again, because the electron density at the ortho and para positions is less. You can also do that analysis, but for activating and deactivating groups, looking at the electron density, what is the distribution when you do the sigma complex, and why is that? Here, I'm just doing the analysis over to the substrate, not in the sigma complex, but you can do both. So the summary is that these groups are deactivating, they remove electron density from the ring, and that's why they are deactivating. And most of them, but we have one important exception to mention here. But most of them would be meta-directors. And here I'm coming with the exception to that. Notice that the nitrogen group, both by induction, so there is a dipole if I have my aromatic ring here again in my nitro group. There is a dipole. So nitrogen is more electronegative than carbon. So it is removing electron density by induction, but also by resonance. So in this group is really strong electron withdrawing group. Okay, so we're going to analyze now another case, but in another video, our exception. But for now, keep in mind, all of the activating groups are, they react faster than Mercy. That's why they would say they are activating, and they are orthopara directing to another substitution. And we have one exception, but many deactivating groups, so the ones that react slower than Mercy, are meta directing. An example of that is the nitro group.